Hello, and welcome to this training session for Intelligent Hearing Systems Evoked Potential products. Today, I will walk you through techniques for optimizing your Evoked Potential testing setup in order to acquire the best quality EP recordings. Begin by requesting an electrically shielded, properly grounded, soundproof booth or room for testing. If one is not available, then request a quiet room, preferably away from roads, construction activities, MRI machines, and other devices that may produce electromagnetic interference, also referred to as EMI. You should never test in a room containing power lines or breakers. Room lighting should be rated as no EMI. Equipment needs to be set up in a methodical fashion. IHS recommends a wooden or plastic non-conductive work surface when placing the system components. Each system component must be isolated from any metal surfaces. The same is true for the patient's setup location. Patients should be set up on wooden or plastic non-metal and non-conductive chairs and beds that recline and are comfortable for testing. For ABR and ASSR testing, it is best that patients sleep comfortably. Computers must have a 3-prong grounded power supply and cable. If interference occurs during testing and you are using a laptop computer with a built-in battery, then try running the laptop on battery, disconnected from its power supply. Ensure that the battery charge is adequate to complete the test. When using a medical-grade power isolation transformer, make sure it is connected to an earth-grounded outlet. All interconnected equipment, even if switched off, should be connected to this transformer. Please note that duet devices do not require an isolation transformer unless it is being used in the OR or it is set up on a metal cart. If the isolation transformer is not earth-grounded, then you will create a floating ground, and it is then preferred that you bypass the isolation transformer and connect the device directly to an earth-grounded outlet. All components connected to the computer must be connected to the same ground. Grounding the IHS device is the most important component to ensuring good quality recordings during testing. I emphasize that the system, the computer, 3-prong grounded power supply, and any peripherals such as the printer needs to be connected to the same ground. You can check the grounding on room power outlets using a ground check plug as shown here. If the device is set up on a metal cart, then you will require the use of an isolation transformer and the cart must be grounded to the isolation transformer. This is done by connecting a grounding cable as shown here from the isolation transformer to the post of the metal cart. Connect the U metal piece under the screw of the isolation transformer and tighten. Then connect the other U under the screw that is located on the post of the metal cart and tighten. Here is another example of the grounding connection on the current IHS mobile cart. Secure connections for all power supplies are important. If the device has an external power supply like the Universal Smart Box, then secure the power supply to ensure that the cable is not loose or slipping out where it connects to the device. Other devices may contribute to noise interference. We recommend that devices that contribute to noise interference, such as a printer or a tympanometer, or any other medical device installed on the same computer or cart configuration or located in the same room, be disconnected and switched off during testing. All energy-saving lighting should be switched off. Do not use light dimming switches in the testing room as these are a high source of interference. Turn off all mobile phones in the room, verifying that patients and caregivers comply. TVs should be turned off and not on standby. Remove battery-powered wristwatches and place far away from the equipment and patient. Unplug any power adapters of non-essential equipment. Unplug any non-essential networked computers in the room, remembering to remove the network cable from the data socket located on the wall or cable paneling. Now let's discuss patient and equipment cable setup. Keep distance from power outlets. Do not position equipment near sockets or power line mains. If a bed is used, move it away from any wall with mains sockets. Next, maintain distance from the patient. Position equipment at the end of the bed on the patient's head side, but as far away from the patient as possible. When testing a child, position the child's head towards the center of the room, not the wall, especially if there's a system of shafts or conduits for power at the head of the bed. For babies in child seats or being held by a mother, position at least 1 meter from the equipment and the cables. Be prepared to suggest alternative positions for patients in order to obtain good quality EEG. Use blankets and pillows to support the patient's neck. Use non-conductive materials and surfaces across any point where cables, equipment, and patient may touch. The bed, chair, or car seat framing may have metal components that will act as an antenna and pick up unwanted EMI. It is important to isolate the patient and equipment from these metal surfaces. Lastly, manage cable positioning. Do not cross electrode leads over transducers, USB cable, and/or power cables. Cables must not cross each other. Run electrode cable and leads from one direction to the patient and earphone cable from the other direction to the patient. Typically, insert earphones will come from behind the patient's head, and the insert earphone speaker boxes will be clipped to the pillow and beside the patient's ears. The patient cable and leads then run down the neck and to the side shoulder, or down the chest of the patient. When using Duet platform, make sure the patient cable is pushed in all the way into the patient connector on the Duet box to ensure a solid and proper connection. Loose connections can pick up noise and affect the quality of your recordings. For all OptiAmp devices, ensure that the electrode leads are well connected to the input jacks of the OptiAmp transmitter and not loose. Change the electrode leads to a new set or different type if any interference persists. IHS recommends braiding the electrode leads to minimize the noise pickup and reduce your common mode rejection. If artifact continues to be a problem after braiding the leads, then try to use shorter electrode leads. Leads should not be older than a year. Depending on the volume of tests, IHS recommends that leads be replaced every 6 months to a year. You can use your device components to detect noise in the environment. Check the room for spots of electrical interference. For users of the OptiAmp transmitter, simply turn on the transmitter and move it around the room and view the incoming EEG for all channels. For Duet users, you can move the Duet box around and evaluate the input signals from your environment on the EEG display window. You can also place the patient cable and the electrode leads at the site of testing and analyze the EEG. Avoid testing at places where the electrical noise shows high amplitude or saturating EEG, cyclical EEG, large spikes, or other EEG anomalies that are not the desired low amplitude, steady EEG typically viewed when a patient is calm and sleeping. While you are trying to identify the sources of the interference from the incoming EEG display, you can also acquire a one-sweep average with filters wide open. For example, say you set your high-pass filter to 1 Hz or 0.1 Hz, while your low-pass filter is set to 3000 Hz or 5000 Hz. Whatever the available bandpass value will depend on the device platform being used. And then set your amplifier gain and artifact rejection. Adjust it so as to accept large signals. For this type of evaluation and analysis, open the artifact rejection to 100%. You may need to modify your display time region to include the pre-stimulus. Use the cursor feature to measure and estimate the period of any waveform. The software will calculate its frequency in the difference indicator as shown in the parentheses. Note, myogenic activity from a patient will fluctuate. Link the frequency of interference to its likely origin. Some countries' power line noise will have a period of 16.5 milliseconds, or 60 Hz, and others will have a period of 20 milliseconds, or 50 Hz. If interference is clearly 60 or 50 Hz mains, and all efforts have failed, including obtaining approximately equal and low electrode impedance to reduce it to a workable level, then the use of a notch line filter may allow testing to continue. You can turn on the line filter from the EEG and amplifier screen for each channel. Now let's move on to the electrodes and how these choices can affect your recordings. For example, in ECochG, Intelligent Hearing Systems manufactures the Lily TM WIC electrodes. These non-invasive electrodes sit at the tympanic membrane, allowing for the collection of more robust and repeatable electrocochleography responses. The WIC option is the perfect compromise and smart choice between the invasive transtympanic electrode and the non-shielded, further away from the site of generation, in-ear canal tip-trode electrode. The WIC electrode is connected to the companion shielded electrode cable, manufactured with industry-standard electrode lead connectors. The shielded ground extension reduces noise contamination of responses and provides for enhanced signal-to-noise ratios. When using snap leads, IHS recommends the use of AMBU neurology electrodes specifically designed for the type of evoked potentials we're acquiring. The AMBUs must be conductive and not expired. When storing a package of disposable snap electrodes, they must be sealed tightly in a Ziploc bag in order to prevent them from being exposed to the elements and drying out and losing their conductivity and function. Make sure that when placing on these electrodes that you press down on the white outer rim to adhere the snap electrode to the skin. Do not press in the center on the conductive sensor, as the gel may spread and compromise the adhesiveness of your electrode. Electrodes that lift up or slide off during testing will pick up more noise and affect the quality of your recordings. Use skin prep pads to prepare the skin and SpectraGel or 1020 conductive paste as necessary to enhance impedances. Ensure that you are using the correct electrode montage, especially at a site where different machines may be used. Different machines have different naming conventions for their connections, thus verify the electrode montage connections to the device. A typical ABR electrode montage is high forehead as your positive electrode and the negative electrode just behind the ear and level with or slightly lower than the ear canal auditory meatus, allowing for bone conduction placement above. It is a common mistake to place the positive electrode too low and the negative mastoid electrode too high. Odd-looking responses can be recorded if the electrode leads are incorrectly connected. Responses may be inverted if polarities are reversed. Here are examples of cervical vamp, C-vamp, and ocular vamp, O-vamp electrode montages. Electrode placement for these types of tests is critical for response amplitude. For example, for C-vamp, the positive electrode on the SCM muscle must be placed on the thickest inner part of the top 1/3 of the muscle, and both the left and the right SCM positive electrodes must be on the same horizontal plane. For O-vamps, it is critical that the positive electrodes be placed as close to the eyelash line as possible in order to ensure that it is being placed on the inferior oblique muscle. Now we move on to impedance. To check impedance on devices using the OptiAmp transmitter, turn the rotary switch to every position of the rotary switch dial. Ensure that the rotary switch on the OptiAmp is switched from impedance check to the on acquisition position when you are ready for testing. For duet, USB Lite, and solo devices, impedances are checked via the Check Impedance button directly in the software. Impedances should be balanced and equal across all electrode sites. In other words, impedances of 1 kiloohm across all sites is better than a mix of impedances of say 1K, 3K, and 7K. The closer and lower the impedance are to 1 kiloohms, the better the quality recordings you will get. If you need to lower impedances, Please re-prep the skin and reapply electrodes. Ensure the transducers being used are compatible with the SmartEP and the SmartEP ASSR system. Only transducers supplied by IHS are compatible with IHS devices and will have the proper connector, impedance, and calibration. All IHS devices use 300 ohm ER3 insert earphones and 300 ohm B71 bone conductors. Duet devices with version 1.4 or higher are compatible with the 10 ohm B81 bone conductor. Duet devices with versions 1.5 or higher are also compatible with the high-frequency ER2 insert earphone. Now let's chat about special techniques to note when using transducer. Exercise care to avoid occlusion of the ear canal associated with pressure, especially transverse, when using supraoral headphones. Likewise, debris can occlude a canal when an insert is placed. Make sure to do a thorough otoscopic examination prior to inserting ear tips in the ear. Bone vibrator pressure and placement should be consistent if variation in stimulus level during testing is to be avoided. Always inspect the sound tubes and make sure that there are no cracks on the tube that may be causing sound leakage, thus attenuation of sound and decibel losses. Make sure that the tube length used on ER insert earphones is the standard ABR length. Do not connect additional tubing to the standard ER insert earphones. If different tubing is used, then you must remove the current tubing and replace the new tubing directly on the speaker boxes of the ER insert earphones. A calibration check should be performed on-site immediately prior to use. When using the ER3C insert earphone, make sure that the red and blue quick disconnect cables are pushed in all the way into the black speaker boxes prior to testing. Carry out a listening check if no responses are seen or unusual waveforms are recorded. Keep electrodes plus their leads away from the bone vibrator and its cables. Use practical positioning that will not diminish response, particularly important for recording the cochlear microphonic. When testing by bone conductor, the vibrator should be above the level of the mastoid electrode. If there's no response, when expected, it is worth checking the vibrator placement. Once you are ready for testing and have loaded your appropriate settings file with all your acquisition parameters, it is time to set the artifact rejection region. Artifact rejection is an amplitude-based technique and should be set appropriately depending on the EP type. The percentage varies and depends on the gain value used. Artifact rejection should be set such that only the largest 5 to 10% amplitude of the EEG is rejected. Note that many more sweeps will be needed to average out noise. Thus, it is important to begin the acquisition with low noise conditions. Testing in a sedation or operating room has its own set of recommendations. Operating rooms are usually acoustically noisy. Insert earphones help attenuate ambient noise and are safer in cases where blood could make an electrical connection between the patient and the transducer. But the insert earphone transducer should be held with a drip stand at a higher level than the tip to avoid blood entering the transducer under gravity. ORs are also electrically noisy. The use of diathermy machines in adjacent ORs can be problematic. Autoclaves and microwave ovens also radiate interference, as do hospital pager systems, elevators, escalators, air conditioning systems, etc. Mobile phones should be turned off during testing. Pulse oximeters are sometimes a source of electrical interference. Try turning it off to see if this eliminates the interference. And if it does, then negotiate with the anesthesiologist to do without if possible. If a pulse oximeter is used, position it as far away from the patient and equipment as possible. Place at patient's feet end. Run oximeter on battery if this eliminates interference and is available. Log the pulse oximeter serial number if noise interference problems occur, and try to avoid using the ones causing a noise problem in the future. If the pulse oximeter is plugged into mains power, use sockets away from those used for the ABR equipment. ABR equipment should always be connected to its own dedicated grounded outlet away from anesthesia machines and other machines that contribute to noise in the recordings. Try to negotiate carrying out testing at OR quiet times. Now let's finalize our presentation by reviewing some good clinician practices. Always log the room number and location on the data results form, unless the tests are always conducted in the same room. Make a note of any adverse conditions observed in the session. IHS also recommends that the electrode leads and patient cables be replaced once a year. Request assistance to transport heavy equipment. Secure leads and wires before transport or transit to prevent trailing or falling from the trolley or cart. Refer to hospital guidelines on sterilization of equipment, electrode leads, and transducers. Always use single-use electrodes and take necessary precautions to avoid cross-infection via electrode prep paste or electrode gel container. Visit our online catalog at catalog.ihsys.info for more information on supplies available for your equipment. We hope you've enjoyed our presentation. This video contains information from the UK's NHSP recommendation document. If you're interested in any of the compatible lines available from IHS, or if you're not currently a Duet user and would like information on this innovative clinical solution, please contact our sales team at sales@ihsys.com. Thank you for watching this training video. If you have any questions or suggestions, please contact our support team at support@ihsys.com.